recording, right? Do I have to hit something else? Okay. Where's start broadcast? There it is. Okay.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone to the Unitronics webinar on data logging. My name is Daniel Logie. I'm an applications engineer here at Unitronics. As I mentioned today, we'll be presenting a webinar on data logging. The goal of today's presentation is to provide an overview of the Unitronics data logging options. And hopefully by the end of the webinar, you will know which data logging option is right for you and the system you are building. The data logging options that we have available are vector logging, Uni DDE, data tables, data export, and SD cards. Each of these data logging options will have their own webinar available. Today, I will be presenting the pros and cons to each and providing an example. The first data logging option that we will discuss is vector logging. Vector logging uses a group of operands, known as a vector, to store data. An example of a vector would be MI0 to MI19. This would be a vector of 20 MIs. The advantages to vector logging are that it is easy to implement in ladder. It is easy to display the vector on the HMI screen. We have the vector tools in VisiLogic available to us, which allows us to manipulate the vector. We can get the minimum value in the vector, the maximum value in the vector. We can find an average. We can organize the vector. We'll be going over these tools in a moment. This type of logging is ideal for small amounts of logging. The disadvantages would be its limited size. We are limited to the number of operands that we have to work with in VisiLogic. And the other disadvantage would be that the logging is local to the PLC without some type of standalone software. At this point, I would like to do an example of vector logging. I prepared this example this morning. I will go online in VisiLogic and I will use remote access to display my HMI screen. I'm using a V1040 and I have a type K thermocouple, and I am logging the degrees in my office in Fahrenheit. I'm logging the temperature once every 5 seconds to a group of 20 MIs, MI0 to MI19. Currently the temperature is holding steady at 79.7. If I place my hand on the thermocouple, after about 5 seconds, the temperature will increase. And again, after another 5 seconds, we will have another new value. I'm using what we call a FIFO logging system in this situation. The first value in is stored in the first MI, and the oldest value falls out of the vector. We can also view the vector here in the Operands tab in VisiLogic. we see the first value that enters the vector is the first value that drops out. Now this type of vector logging is ideal for an operator or user who will be interacting with the HMI display. If the user needs to monitor, in this case the temperature, for the last 100 seconds, this option is ideal. More information on vector logging can be found in the webinar Vector Programming available on our webpage. The next form of data logging that I would like to discuss is Uni DDE. Uni DDE is a software available on our website. It is a standalone software, and it allows you to view and interact with a vector of operands in Excel. The advantages of this type of logging would be that it is in real time. The Excel updates in real time. We can remote monitor the information, meaning we can be far away from the PLC. We just need a Ethernet or serial connection. We can have remote interaction with the operands. This is very useful, and this will not be the case in some of the softwares I will present in this webinar, is that we can change operands, modify operands in Excel using Uni DDE and send the new value to the PLC. Another advantage is that we have the Excel tools at our disposal. Once the vector is in Excel, we can use the graph functions, or put it in a bar graph. It can also be used as a simple SCADA in this way. We can monitor multiple PLCs, multiple vectors, and we can graph the vectors, and it can be used as somewhat of a simple SCADA. The disadvantages of this type of logging is the limited size. Since we are reading vectors, we will again be limited to the amount of operands in the PLC. And also in the Uni DDE software, we are limited to 50 operands per vector. Now we can monitor multiple vectors from multiple PLCs, but the maximum is 50 operands per vector. So what I would like to do now is an example of Uni DDE. Here is the Uni DDE software, again available for download on our webpage. And you'll see here that I have one PLC defined currently with two vectors defined. I'll open up the first, and we can see that I am reading the operands. The operand type is MI, the start address is 0, and the length is 20. So I will be reading a vector of 20 MIs starting at MI0. If you can recall the previous example, this was where my temperature value was being stored, MI0 to MI20. If we open the second vector, I will be writing this vector, so I'll be going from Excel to the PLC. I will again be using the type MI, start a vector 50 with a length of 1. So I will be writing a value from Excel to MI50. And I will choose OK, and I will run the Uni DDE software. And here is my Excel that I built for this example. Here you can see my temperature values updating in real time. If I hold my finger on the thermocouple, we see the temperature get slightly higher. And again, it's updating once every 5 seconds. To the right, I have this vector graphed. So again, we can use all the Excel tools that we have available. Now this was the vector that I was reading. Next, we're going to write a value to the controller. So I will use remote access in VisiLogic to monitor my HMI display. And I will navigate to screen 2, where my current set point is 80. This set point is MI 50. This is the value that I decided to modify. So if I jump back to Excel, I can change the value to 600. Now I built a macro in Excel and I linked it to this button here. So when I press this button, the value 600 should be sent to the PLC, MI 50. So I will send that value now. And we see that the value on the display has updated to 60. I'll change it one more time, maybe 230, 300 with a 1 decimal offset. I will send it to the PLC, and I can view my HMI screen, and MI 50 updates to 30. That is 300 with a 1 decimal offset. So this type of logging would be ideal for a manager who might want to monitor production of several units. He could monitor the production of the current hour in real time as it updates, and he could also monitor the last few hours of production and place it on a graph. He would not be limited to one PLC. He could monitor multiple PLCs all at once. So for more information on Uni DDE, please visit our website in the webinar Uni DDE. The next form of data logging that I would like to discuss would be data tables. Now, data tables are built into VisiLogic, and they are in spreadsheet format. The advantages of the built-in data tables to VisiLogic are that they are very easy and convenient to set up in the ladder. They can be referenced in the program, meaning once they are in the data table, they can be recalled and the data can be used in the program. We have all of the data table tools at our disposal in VisiLogic. And this type of logging is also ideal for recipes. If we would like to store recipes on the controller and recall them to the ladder, this is very doable using the data tables. Some disadvantages would be its size. Now these data tables are much larger than the two options we discussed previously. However, they are still limited to 120K. They are also local to the PLC. Without some type of third-party software, or third standalone software, they will be local to the PLC. They can be rather difficult to display on screen. So at this point, I would like to do an example of data tables. I can bring up my VisiLogic data tables one of three ways. Using my data table icon here, I can open my data tables from the drop-down menu here, and also from the project tree. Now here are my data tables. I currently have one table defined. I have 5 columns. 3 of those columns are reserved for temperature. The other 2 are reserved for the time and the date. And I have 500 rows that I'm currently logging. Now I can go online with the PLC, and I can view my information as it's being logged. We see I'm logging the information once every second. It also shows us the date, and I'm logging 3 different temperature values. So you can see how much more we can log, how much more information we can log using the data tables as opposed to the vector logging. If we go offline and view the memory requirements of the data table, I'm currently taking up about 1/8 of my memory available for data tables. Just as a side note, these tables can be exported to and from Excel. So we can export the table to Excel. We can also import the table from Excel. So even though they are local to the PLC, we do have tools to retrieve the data and input additional data. Now before I move on, I would just like to go over a few data table tools in the VisiLogic ladder. We can read a row and write a row. We can read a column and write a column. We can clear tables and rows and columns. We can use the data table find feature, which will search the data table for some value, whether it be a name or a time. And there are a few additional features here, so all of these will be at our disposal when we use data table logging. An ideal situation for data table logging would be recipes that are going to be used in the program, or any case where you actually have to reference the information that you are logging. More information on data table logging can be found in our webinar, Data Tables Programming, Parts 1 and Parts 2. Next, we'll talk about data export. This is a standalone software available at Unitronics.com. Data export allows the user to extract Unitronics data tables from the controller and populate an Excel file. So the data tables that were just covered in this webinar can be extracted to Excel using data export. The advantages of this software is that we can remote monitor. There is no need to be in front of the PLC. We can monitor the information using an Ethernet or serial connection. It's very easy and convenient to set up. There's very little maintenance once we do set it up. The software simply runs in the background of your PC and calls the data tables. Size is a very, very big advantage to data export. We are, of course, limited to the size of the data tables on the controller. However, we can set up a schedule to call these data tables back to your PC, populate the Excel file, and then clear the table. So really, we're limited to the amount of space you have on your PC. As I mentioned previously, data export is set up on a schedule. We can pull the data tables once a minute, once an hour, twice an hour, once a day, twice a day, once a month. We can also have the PLC initiate the call if we are using Ethernet. So once the data table is filled in the controller, the PLC can initiate the call to data export and send the data table to your PC. The final advantage of data export is that it is very customizable. It allows us to choose which data table we would like. It allows us to choose a range if we wish, which is a vector of operands. It allows us to choose a schedule or multiple schedules, multiple PLCs, and it also allows us to send an email of the file once we have finished. So some of the disadvantage of data export would be the fact that the data cannot be recalled. So once the data is sent to the PC, if the data table in the controller is cleared, there is no way of recalling the information that is sent to your PC. This information that's on your PC also cannot be referenced. The final disadvantage would be that it requires a dedicated PC connection. So based on your time schedule, data export is going to attempt to connect to your PLC, and if a connection is not available, it will not take place. The data export software will not be able to retrieve the data tables from the PLC. So at this point, I would like to do an example with data export. Here is the data export software, again available on our website, Unitronics.com. Currently, I have 2 PLC sites configured. One is set up on a time schedule in Ethernet call mode, meaning that data export will call the PLC and instruct it when to send the data table. The other site is set up for Ethernet listen mode, meaning the PLC will initiate the connection and send the data table. As an example, I'll open up site number 2, which is my Ethernet call. And here we see I must input my connection settings. And it asks me what file type I would like to create, a CSV or an Excel. If I would like to use an Excel template, I may. It asks me for the starting position, how many cells from the top, and how many from the left. And it also gives me the options to select a schedule. Currently I have once an hour selected. It allows me to select which table. I have the temperature table selected, which was just demonstrated using the data tables in VisiLogic. I can select a region, which would be a vector of MIs or a vector of operands. And I can also add an email. So I can run the software. It's going to prompt me that I must save it first, and I can select OK. And here is my call log. Now we could wait an hour until it is time for data export to call into the PC or PLC based on the time schedule I have set up. Again, once an hour, data export is going to call the PLC. Or I can force a call using this icon here. I will force the call, select my site, and choose OK. And we will see that this is call number 1. The call succeeded. It was a user request as opposed to schedule-based. Now, this Excel file, or this data table, is saved as an Excel file in a folder on my desktop. We will navigate to that folder in a moment and open up the file. But before I do that, I would like to demonstrate how the PLC can initiate the call. So I'll use remote access in VisiLogic. And I will navigate to my third HMI display. And we will see Call Data Export. I have a button to connect. I will click my connect button. And we will see a second call appear in the data export call log. We will see the call succeeded. The call trigger was the PLC via Ethernet. And it is my second. We can also see the next call that is scheduled in the bottom left-hand corner here. It is scheduled for 2:50. Currently, it is 2:16. So in approximately a half an hour, there will be another call based on the time schedule that I have prepared. We're not going to wait that long. What I'm going to do next is navigate to the folder that I have set up on my desktop. And in my data logging folder here, we see the folder called PLC. Now this folder was created by Data Export to store my Excel files. If I open up the PLC, we see that I have my Excel file here. If I open it up, here is the data that we requested from the PLC data tables. We see all 500 rows and all 5 columns. It also adds a 6th column for the row number. Now this type of logging would be ideal for maybe a supervisor who would like to monitor monthly production. The supervisor can simply have data export running in the background of their PC and call various data tables from various PLCs. Data export will automatically populate folders for the supervisor on their desktop. For more information on data export, please visit our webinar, Data Export, available on our website, Unitronics.com. The last type of logging that I would like to discuss are SD cards. A controller can store data to an onboard SD card. Now, the advantages of this type of logging is that we can set it and forget it. We basically set up the SD card and we set up the ladder logic to tell us when to save to the SD card. And we can leave the controller for a month, 2 months, a year, and when we return, all the data will be saved to the SD card. There is no need for a constant connection. So the advantages to SD cards, along with the no need for connection, is the size. We can use up to a 32 gig SD card. There is very little maintenance once we set up the ladder logic and tell the controller when to store to the SD card. Again, we can walk away and come back. All of our data will be retained. We have the SD tools in VisiLogic available to us, which we will cover in a moment. SD card suite is a standalone software available from our website that helps us interact with the SD cards and the logs. And the final advantage is that we are not limited to logging simply data tables. We can log trends and alarms as well. The disadvantages to SD card logging is that there is slight programming involved. And we must perform file conversion to view certain file formats from the data logging. So we have to use SD card suite to convert the files. At this point, I'd like to do an SD card example. And I'll refer to my VisiLogic project. And I will use my remote access. And I will navigate to the fourth and final page on my V1040. And we'll see that I can log to a CSV. If I press down, we are currently logging a CSV file to the SD card. I can stop the logging for a moment and continue if I wish. I'll let it log for another moment. And I'm currently logging once a second. And I'm logging the 3 temperatures, the time, and the date that we've been using throughout this webinar. I can also log the entire data table to the SD card, meaning the entire Unitronics data table. I can log that to the SD by simply clicking that button. All right, now that we have a CSV file and a UDT file, I'm going to introduce SD card suite. Again, this is a software available on our webpage. We have SD card manager, which allows you to view the SD card content when the SD card is local to your PC, meaning we have to remove the SD card from the PLC and have it interact directly with your PC. We also have SD Card Explorer, which allows us to remote monitor the data inside of the SD card. It's important to note that with SD Card Explorer, we cannot open alarms or trends. So I'll open SD Card Explorer at this point because my SD card is inside of my 1040 currently. I'll open my settings, and I'll check my connection. And I will open the contents of my SD card. Now, if you remember, we stored a full data table which I stored in Data Table 1 folder, and I can open that. And here is my data table that was local to my PLC a moment ago, with the 3 temperatures, the time, and the date. I can export this to Excel, but it is in UDT format currently, so I do need data or SD card sweep to open this file. If I tried to open this file directly from the SD card, I would not succeed. So I will close the full data table, and I will open my Excel file that I created just a moment ago. I can open this file, and I see that it is in Excel format. I have my 3 temperatures, as well as my time and my date. I have it set up so that while my logging button was pressed down, I was logging the 3 temperatures, the time, and the date once a second to my CSV. So you'll see we have a total of 26 rows, meaning I logged for a total of 26 seconds. This is completely customizable. You can log whenever you wish. So as I mentioned previously, this type of logging is ideal for situations where the PLC will not have a Ethernet or serial connection, and you are storing a large amount of data. For example, on an oil rig, there's very little chance that you will have an Ethernet or serial connection to the PLC. You can simply place an SD card into the PLC and set up the program so that it will log to the SD card. When the oil rig returns or docks, we can retrieve the SD card, and all the information that we wanted stored is available to us. For more information on SD cards, please visit our webinar, SD card programming, on our webpage. Now, just as an overview, here are the list of data logging options that we covered today with their corresponding webinar. Vector logging can be found in vector programming. Uni DDE can be found in the webinar Uni DDE. Data tables can be found in Data Tables Programming, Parts 1 and Parts 2. Data export can be found in the webinar Data Export. And SD cards can be found in the webinar SD Card Programming. That concludes our webinar for today. Thank you.